So, what is cloud native? Can I benefit from using cloud native technologies and approaches in my work? And will this be beneficial for my career? The answer to all of this is an absolute yes. For us to fully understand what cloud native is, let's take a step back, because when something's hip and cool and in demand like cloud native, naturally everyone and every company will want a piece of it. If you go and search for cloud native, you're going to see this referenced everywhere. You'll see many products and many services claiming to be cloud native. Some of them will be, some of them won't. So the real question is, what actually makes something cloud native or not? From a computing viewpoint, cloud is often associated with one or more of the typical cloud service providers such as AWS, Amazon Web Services, Microsoft Azure, or GCP. However, the word cloud in cloud native is completely open, with no favoritism whatsoever towards public cloud. Instead, it applies to all cloud offerings, your public, your private, and your hybrid clouds. The word native in the Oxford Dictionary is referred to as designed for or built into a given system. When you combine the two, this then aligns quite well with what we can actually consider as cloud native philosophies. And this is my preferred way of actually breaking down and explaining what cloud native actually means, rather than actually thinking of cloud native as a binary state of a 1 or a 0, where something is or isn't cloud native. It's better to think of cloud native as a collection of different philosophies, and something may actually align to one or more of those different philosophies. Take, for example, cloud native architecture. With this philosophy, applications are built and designed using cloud native best practices to run across all cloud native systems. Again, all variations such as public, private, or hybrid clouds. There's also other philosophies, so there's cloud native culture, where different personas in an organization promote and drive change using cloud native practices, and therefore encourage others also to utilize optimal approaches in their designs or builds. To understand a difficult topic, it can sometimes help to explore what something is not. So, a good example, someone might actually state, my application is cloud native as it runs in the cloud. It's fair to say that an application designed to run in the cloud is a step in the right direction. This would have advantages over a legacy deployment, and many, myself included, would actually see this from a positive perspective. With what we actually know from this small amount of information, we could actually derive that the application is able to utilize and benefit from the cloud service provider's infrastructure. It would have a guaranteed level of availability, again, as per the cloud provider. It could make use of that provider's APIs for ease of management. But by adopting cloud-native philosophies, principles, best practices, we could significantly progress an application further. For example, we could question, is this application automated in terms of its setup and delivery? Has the application been designed with resilience to protect from failure? Can the application automatically scale based on its operational workload? And is the application secure by default? These answers really help in understanding whether or not an application aligns to cloud-native approaches. We can see with this simple question alone, cloud-native is much more than just a yes-no binary answer, and cloud-native can actually cover a wide variety of areas, especially with each of the different cloud-native philosophies being wide open. If you're ever asked if your work or your efforts are cloud native, rather than actually giving a yes or a no answer, Personally, I think a better answer is to actually say, my application makes use of the following cloud-native approaches. Another example, cloud-native is all about running my application in a container. The cloud-native ecosystem emphasizes and focuses on the benefits and the use of container technologies. However, using containers does not necessarily equal cloud-native. Whilst this could actually be a step in the right direction, it's also important that approaches like containerization are used correctly and effectively. To elaborate, an application running in a container doesn't necessarily make it cloud native. It's possible to run an application in a container using many different container runtimes. We could, with relative ease, run an application using a single command line with Docker, Podman, or Containerd. Containerizing an application is beneficial from an application management perspective, and it's definitely a positive step towards cloud native. However, as it is with this example, it actually shares many of the problems that you encounter when running an application on a single system. For example, what happens if the system running this container was to error? What happens if the workload of that container increases past our host limits? What happens if we have a noisy neighbor? Cloud-native methodologies, best practices, and approaches are able to address these very issues, and many of the techniques and approaches are derived from the lessons learned by technical organizations over the last decade or more. Therefore, to understand cloud-native together, we're going to take a closer look at the different cloud-native philosophies. So these include architecture, community and governance, personas, and open standards, and all of which relate to 16% of the KCNA curriculum. Before we do, we'll start by looking into some of the main players in the cloud-native computing space whom you should be aware of in general and for the KCNA exam. So firstly, the LinuxFoundation. In 2000, the LinuxFoundation was founded as a merger between Open Source Development Labs and the Free Standards Group. The aim to standardize Linux, to support its growth, and to progress commercial adoption. As your author and an individual who leveraged Linux during this period and worked through this time where many other Unix variations flourished, so your Sun Microsystems and Solaris, it's evident that the LinuxFoundation was incredibly successful with its directives and goals with Linux. It is now the de facto standard for Unix-based operating systems. The LinuxFoundation, as an organization, sponsors the creator of Linux, so Linus Torvalds, and lead maintainer Greg Crow Hartman. In addition, many technical corporations, including Google, Intel, Meta, Microsoft, and Samsung, in turn, also support the Linux Foundation. The Linux Foundation is also responsible for hosting significant projects that include the Linux kernel, Kubernetes, and the CNCF. If you're interested in learning more about Cloud Native, the Cloud Native Computing Foundation is a place to start. They are the primary organization responsible for promoting and developing cloud native technologies. In February 2015, Kubernetes hit its first major milestone of version 1.0. It was deemed stable and ready for production. With this success, Google donated Kubernetes, the first ever project submitted to the newly created CNCF, the Cloud Native Computing Foundation. It is an open-sourced, vendor-neutral hub focusing specifically on cloud-native computing. The CNCF are responsible for hosting Kubernetes amongst other projects including Prometheus and Envoy. and this allows these projects to be maintained and managed in a vendor-neutral space. The CNCF oversees hundreds of projects, and these projects have received over 10 million contributions. The CNCF is a great organization, and on your cloud-native journey, knowledge of the Cloud Native Computing Foundation and their parent company, the LinuxFoundation, will further cement the overall cloud-native picture. That's it for this one. We'll continue exploring cloud native by looking further into the specific philosophies and areas that form cloud native. I'll see you in the next video.